So, what do things like a chessboard, a tiled floor, and even the area of your room all have in common? Well, they're all built on a special kind of number that's like hiding in plain sight. Today, we're going to uncover the secrets of square numbers, and I promise, once you see the pattern, you'll start spotting them absolutely everywhere. Here's the game plan. First up, we're going to nail down what a square number actually is. Then we'll literally see why they're called squares. After that, we'll get into their opposites, the square roots, uncover some really cool hidden patterns, and finally, we'll tie it all back to the world around us. All right, let's dive right in with the most basic question. We hear the term square number thrown around in math class, but what does it really mean? What makes a number like 9 or 16 so special that it gets to be called square? And honestly, that question is everything. Why square? It's not just some random name someone picked. The answer is the key to understanding this whole thing.
Okay, so here's the official definition. A square number is simply what you get when you multiply any whole number by itself. So, for example, 3 times 3 gives you 9. Boom, that makes 9 a perfect square. The key idea here, the thing to always remember, is a number times itself.
And mathematicians, they love a good shortcut, right? So instead of writing out 3 times 3, they use this little notation, a 3 with a tiny 2 floating up top. We read that out loud as 3 squared, and it's just a quick, clean way to say the exact same thing. So let's get these first few locked in our brains. Here are the first 5 square numbers: 1, 4, 9, 16, and 25. You're going to want to get familiar with these, because they're the building blocks for all the cool patterns we're about to find.
Okay, so we've got the definition down, but now for the really fun part. Let's actually see it. We're about to move from just numbers on a page to a visual that's going to make the name square number just click.
This is so cool. Check this out. With just 1 dot, you have a little 1 by 1 square. With 4 dots, you can arrange them into a perfect 2 by 2 square. Take 9 dots and you get a perfect 3 by 3 square. And 16 makes a 4 by 4. See what's happening? Only these specific numbers can form a perfect solid square shape with no missing pieces. And here is the aha moment. For the number 9, the square it makes has 3 dots on each side. For 16, it has 4 dots on each side. The number of dots along one edge is the original number we squared in the first place. And that's why they're called square numbers. It's literal.
All right, we know what they are, we know what they look like. Now let's get our tools out. In this section, we're going to cover how to actually work with these numbers and their opposites, the square roots.
Now this chart here lays out the first 12 square numbers, and I bet a ton of these look super familiar. I mean, if you know your times tables, you've been working with square numbers for years without even thinking about it. 7 times 7 is 49, 10 times 10 is 100, and of course 12 times 12 is 144. Now, for just about every action in math, there's an equal and opposite reaction. Think of squaring as going forward. You start with the side length, like 3, and find the total area, which is 9. Well, the square root is the undo button. It's going backward. You start with the 9, and you ask, hey, what number times itself gave me 9? And the answer, of course, is 3.
And that reverse journey has its own name, the square root, and it's got this cool symbol called a radical. So the square root of 25 is 5. Why? Because 5 is the number you multiply by itself to get 25. It's really that simple. Just the opposite of squaring.
Okay, this is my favorite part, for real. We're about to put on our detective hats and uncover some amazing secret codes that are just hiding inside the list of square numbers. And that is so true. Square numbers aren't just this random collection. They're all connected by these beautiful and kind of surprising rules. Let's check out the first one. Okay, look at this. It's wild. If you find the difference, the gap, between 2 square numbers that are right next to each other, a secret pattern just pops out. So the difference between 4 and 1 is 3. The next gap between 9 and 4 is 5. Then it's 7. Then 9. Do you see it? The difference is always the next odd number in line. It's this incredible hidden connection. And here's another awesome trick. A perfect square can only end in one of these digits: 0, 1, 4, 5, 6, or 9. It will never, ever, ever end in a 2, a 3, a 7, or an 8. So if someone asks you if, say, 1,437 is a perfect square, you can say, no way, instantly, without doing any hard math, just because it ends in a 7. How cool is that? So, we've explored the definitions and the secret patterns. For our last section, let's bring it all back home. Where do these numbers actually show up in our day-to-day lives? Seriously, they're everywhere once you start looking. Next time you see a tiled floor, just count the tiles in a square section. An 8x8 patch is 64 tiles. A chessboard? That's a perfect 8x8 grid of 64 squares. And when you calculate the area of a room that's 5 meters by 5 meters, what do you get? 25 square meters. It's all over the place. And what this really shows us is that square numbers aren't just some abstract idea from a textbook. No, they're a fundamental concept that helps us literally build and measure the world around us, from the floors we walk on to the games we play. So, we've seen how multiplying a number by itself lets us build a perfect square. And that just leaves me with one last little thought for you to chew on. If these are the numbers that make perfect squares, what kind of numbers do you think you'd need to make perfect triangles? Something to think about. Thanks for joining me.